Ever wonder what really happens when you search for a cat video online? It feels instant, but behind the scenes, a vast, physical network is at work. The internet isn't a cloud. It's billions of computers, cables, and servers all over the world talking to each other. Think of it as a global club where every device speaks the same language, sharing information in tiny pieces called packets. These packets are like Lego bricks, sent one at a time, each with instructions on where to go. If a packet gets lost, only that piece is resent, not the whole file. No one owns the internet. It's a patchwork of networks run by different organizations, all connected. This decentralized structure makes the internet resilient and powerful. It's a digital neighborhood where every computer has a unique address, constantly sharing packets, whether it's an email, a photo, or a piano-playing cat video. So, how does your phone or laptop join this global network? You need a gateway, your Wi-Fi router. The router creates a private network at home, letting all your devices talk to each other and connect to the internet. But to reach the wider world, your router connects to your internet service provider, or ISP. Think of your router as your driveway, and your ISP as the road to the digital highway. Every device in your home sends its requests through the router, out to the ISP, and onto the internet. The router sorts all this digital traffic, making sure each response gets to the right device. It's like a super organized mail sorter for your home's internet. You're online. You type google.com. How does your computer find Google in this massive network? Enter the domain name system, or DNS, the internet's address book. Computers use IP addresses, not names, to find each other. DNS translates easy-to-remember names like google.com into the numerical IP addresses computers need. When you type a website, your computer asks a DNS server for the right IP address. The DNS server looks it up and sends the answer back in milliseconds. It's like looking up a friend's number in your contacts. DNS connects names to numbers. Without DNS, we'd all be memorizing strings of numbers instead of website names. With the IP address in hand, your computer breaks your request into packets and sends them out. These packets travel through your router, your ISP, and then across a global web of fiber optic cables, glass strands carrying data as light. The internet's backbone is physical, cables under streets across countries and beneath oceans. Packets hop between powerful routers, each directing them closer to their destination. They might even take different routes to get there. Eventually, all the packets reach the server, like Google's, and are reassembled. The server processes your request and sends the response back, starting the journey in reverse. All this happens in less than a blink. As your data travels, how do you keep it safe from prying eyes? That's where HTTPS comes in. The S stands for secure. When you visit a secure site, your browser and the server create an encrypted connection, scrambling your data into code only they can read. Even if someone intercepts your packets, all they see is gibberish. Look for the padlock icon in your browser. It means your connection is private. So, from your router to your ISP, through DNS, across global cables, and protected by encryption, the internet is a marvel of engineering. It connects us all, safely and instantly, and you don't need to know every detail to enjoy the magic.